All right, we've talked a lot about incremental sampling and in a general context and even diagrammed a little bit. Now we're going to look at it in a very brief format, but it'll hopefully give you some idea beyond what we've talked about already. As you can see, it's a little complicated conceptually, but it's not that bad, and it's a really good thing. Some of these slides are kind of repeats, so we'll go through them fairly quickly. Again, this was originated in the mining industry where we had lots of heterogeneity, but we also have that here in the environmental world. Core material, we've seen this slide, can be very heterogeneous, and deciding where to sample and what is a sample. Now that we can ask that question and have one common mind about what the problem is of defining a sample. We asked that yesterday, what is a sample within this distance, or what really is appropriate for our use. Okay. According to Piaget's sampling theory, we're looking for trace particles below 1 part per million, 10,000, 1%. And the population is the whole, in this case something not too big. We have a sample defined as something small here, something larger here. You can see again, no particles. Here we get particles. That's more representative of this whole population. And so if we do get that hot particle, then we get a fairly high concentration, whereas that's a lot higher than the average concentration. And so again, the support size is not always representative of the volume. And that's our challenge, is to make it so to the extent possible with enough increments and enough samples. Sampling theory integrates and emphasizes grouping and segregation. One more time, grouping is where particles cluster into little groups like this throughout the overall. Segregation is where you have more of a massive exodus or segregation, whether either on top from the large particles coming up or other particles going to the bottom. This could be a density issue. We have this, of course, in gold, or if you have lead. Side issue, a scoop has to be designed correctly for the increments. We talked about that in the Japanese slab cake exercise. Okay, here are the most difficult, the iconic ones. Again, we had autofluff, we have explosives, pretty good sized nugget in the soil, and then PCBs are also very heterogeneous.